So we've had some success with here's a picture of a cyclic, give us its name. Now, of course, we go the other way. Here's the name of a cyclic, show us its structure. Some of these are line structures that we'll have to draw, and some of them are the dreaded condensed structurals where we have to write all the H's. So let's see what we can do. Cyclohexane is how this thing starts. So 6 carbons in a ring. 2, 3, 4, 5, 6. Okay. So there's a hexagon of carbons. This is hexane, so those single bonds are all we need to hold it together. And now they tell us there's a single carbon attached to one of these, a single methyl group attached to one of these carbons, and it doesn't really matter which it is since that's the only branch. Okay, so now we've got the basic structure of this, and we need to fill in hydrogen. Every carbon has 4 arms. This carbon's used one of its arms to hold on to the ring, so it has 3 left for hydrogen. This carbon is using 3 of its arms, so it only has 1 left for hydrogen. 2, and a spoiler alert, all the rest of these are going to be 2s. When you have single bonds on either side of you, when you're in the middle of a chain like this, that automatically means 2 arms used, 2 arms left for hydrogen. Oh shoot, they wanted line structure. Sorry. So if we're just doing the line structure, we draw a hexagon, and then we put the stick, and we don't need any of the C's and H's. Okay. Now that we've been reminded of the importance of reading the question, let's press on. This is the only one that isn't condensed structural for a while, so I'm learning. It's going to be okay. All right, 3-ethyl, that's a branch, don't care for now. Cyclohexene. So we're doing 6 carbons in a hexagon. 2, 3, 4, 5, 6. And we'll single bond everything just so it doesn't fall apart. Okay, there's cyclohexane. Cyclohexene means there's a double bond. I get to decide where it is. And these carbons are either 1,2 or 1,2. We'll decide shortly. And now they say on the 3rd carbon there is an ethyl group. So if this is 1,2, then the 3rd carbon gets our ethyl, which is a branch of 2 more carbons. And now we tediously fill in hydrogen. 3 used, 1 left. 3 used, 1 left. 3 used, 1 left. Middle of a chain is generally 2. End of a chain is generally 3. And out here where nothing's happening and we're just in the middle of a chain, we get a lot of CH2s. Good. 3-ethyl cyclohexene. 4-dimethyl. The important part here is cyclopentene, so a pentagon of carbons, and we'll single bond everything for starters. It's a pentene, so there's a double bond. I get to put it anywhere I want. Let's go with that. And if these are carbons 1 and 2, then 3 and 4 would get our methyl groups here, so we could put a carbon like so, and a carbon like so. That's unpleasantly scrunched, but there's not a ton of room on this sheet. We'll try to make it work. 2 branches, 2 hydrogens. 1, 2, 3 branches, only 1 hydrogen. 3 branches, 1 hydrogen. 3 branches, 1 hydrogen. 3 branches, 1 hydrogen. And on the ends here, only 1 branch or 1 bond being used, so space for 3 hydrogens. Okay, cyclopropane. 1, 2, 3. I was thinking pent for a minute and started doing a pentagon, but propane is 3 carbons, so this is just a triangle. And it's propane, so all single bonds is fine. 1 methyl group, you can put it anywhere. And now we stick on hydrogens in the usual manner. 2 bonds, 2 hydrogen. 2 bonds, 2 hydrogen. 1 bond, 3 hydrogens. And bonds, 2 hydrogens. Propyl cyclohexane is 6, so hexagon again. Single bonds everywhere. Okay, and hexane, so these are all singles, no need to change anything there. A propyl group is 3 carbons attached to one of these, so C, C, C. That takes care of all our primary and then the branch structure. And for hydrogens, we get 2, all around this ring it's going to be 2s. Whoops, sorry. Except on the carbon which has the branch. This carbon has 1, 2, 3 bonds, so it only has room for 1 hydrogen. And then we get 2s and a 3 on the end. Very normal look for branches. One ethyl, 2,3-dimethyl, that's all branches, don't care. Cycloheptane. Okay. 7 carbons in a ring. 1, 2, 3, 4, 5, 6, 7. Can go a long time without drawing a heptagon. I'm not very practiced at it, but there we are. Heptane, no double bonds to worry about. The first carbon, wherever I choose to put that, gets an ethyl group. The second and third carbons, you could go that way if you wanted, but I've got more space in the bottom right, so I'll go like that. Okay, 1 ethyl, 2,3-dimethyl cycloheptane. And they want condensed structural, so hydrogens again. Two bonds, 2 hydrogens. 3 bonds here, only 1 hydrogen. And CH3 on the end, as usual. 3 bonds here, so only 1 hydrogen, and then CH3 on the end. 3 bonds here, 1 hydrogen, and H2, and H3. Okay, and now we're back to line structures for the last few. 4 ethyl, 3 methyl, that's all branches, I'll ignore that for now. Cyclopentene means 5 carbons in a pentagon. Da, 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 da. A little irregular, but 1, 2, 3, 4, 5 is what matters. Okay, so that's cyclopentene. Oh, sorry, this is cyclopentane. I have to put a double bond someplace, and I'm going to put it here. So that makes, I have decided that these carbons will be 1 and 2. Why did I do that? Because that way 3 and 4 are over here where I have a decent amount of space to include them. You don't want to have your branches in a place where you're really hurting for space, so if you try to plan ahead to put your double somewhere that leaves the branches in a convenient spot. You learn to do that after crowding yourself into a corner enough times doing homework. Okay, so our 4th carbon, this one, gets an ethyl group, and our 3rd carbon gets a methyl group. And that would be the structure. Pentagon, double bond, single branch, and then, sorry, that angle doesn't show up amazingly well, but something like that for the double branch. I can't live with that, that's way too ugly. Yeah. Okay. A little better. Not beautiful, but better. Okay, 6 ethyl, 3,4-dimethyl, that's all branch stuff. We'll get to that shortly. Cyclohexene. 3, 4, 5, 6. 1, 2. Okay, so that's a hexagon. That's cyclohexane. Cyclohexene means we put a double bond someplace. I'll go for over here. So I'm going to say these are carbons 1 and 2. Now they say on carbons, I guess I'll do it from left to right. I was going to do the methyl groups and then the ethyl group, but we might as well do this in order so we're less likely to miss something. Carbon number 6 gets an ethyl group. 1, 2, 3, 4, 5, 6. This gets that's a carbon, so that's an ethyl group. And then carbon number 3 gets a methyl group, and carbon number 4 gets a methyl group. So there's our line structure. Not too bad. Doing the cyclic ones is really not that different from doing the linear molecules we started with. You draw the ring and then you attach branches. None of that has really changed.